Hello and welcome to C2 Part 3, RS232 Command Creation and Editing. RS232 commands are created, viewed, manipulated in the RS232 Manager, which of course is one of the 5 elements of the Compass Control software suite. Here in C2 Part 3, we'll teach you how to learn and edit RS232 commands. In C2 Part 2, we taught you how to learn and edit IR commands. And next, in C2 Part 4, we'll teach you how to learn and edit TCP/IP commands. Testing RS232 codes is quite simple. You use the RS232 Manager on your Compass PC. Your PC must be connected to the MC1000 on the same network. You will choose the desired device port for testing. And you'll connect an RS232 3.5mm stereo to DB9 cable to the RS232 port on the device you wish to control. Those RS232 cables are included with the KD-MC1000 purchase. You receive one 3.5mm stereo to 9-pin male and one 3.5mm stereo to 9-pin female connector. Typically, your RS232 port on the device you wish to control is female connector. And typically, the control processor is a male pinout or 3.5mm. So that's why RS232 with male on one side, female on the other, that's known as a straight through wiring. And it all refers to the transmit and receive pins. When we test codes, you'll have a blink of the selected multifunction port, and you'll also have constantly, of course, the power lit, while a single blink of the amber link light during that test. And so let's go ahead and jump into our RS232 Manager software. We open up the RS232 Manager here. And I will expand the window. And it shows me here where I am, which is in the Key Digital library. And of course, all of our libraries are located in our default directory where it's installed. And if you just let that go to the default location, it's going to be Program Files x86. Key Digital, Compass Control, Library, and RS232 Database. So now I'm going to go to the Key Digital, and today we're going to be working with our audio matrix, Key Digital's audio matrix, model MXA 8x8 Pro. I'm going to jump into the website to take a quick look at that unit to show you exactly what we're working with. The unit is 3 RCAs per input and output for left, right analog and digital audio. The digital audio port can also be composite video. Thus, if you could see that, silkscreen PCM/CV, it says. So each input and output has 3 RCAs, and on the output side, you've got 3-band EQ, volume control, mute, unmute, of course. We also have analog to digital and digital to analog audio conversion taking place. So that's the unit we're going to be controlling. And we're going to start off by testing codes. So I choose the model, so how it's organized here, the brand, the category of products. So for example, if this was Samsung, you would see televisions, Blu-ray players, etc. Here we are, audio video switcher. And we have all of our commands here. They're tabulated. Common all applies to the unit as a whole. Output 1, output 2, output 3, etc. apply to just that specific output. So I can come here and choose, for example, power off command. I'm going to filter my action ID, starting with action ID 1 at the top there. We'll get into action IDs in a moment. Power off. I send that command, and I actually even begin to see some feedback here, don't I? Let's go ahead and power on. Now what we have down here is a terminal, the KD terminal, It's similar to how your computers used to have hyperterminal built in, where you would connect from the RS232 connection on the computer. Well, nowadays they don't typically have RS232 connections. Instead, you need to purchase a USB to serial adapter. And so therefore, they also don't come with the software, the RS232 software any longer typically. So we build it in here. We build it in. And you could see this feedback down in that terminal. If you don't see it, your RS232 Manager window might look a little something like this. You could adjust how much of that terminal view you have, and we could test the commands. When I turn off the unit, of course, the face of the matrix, the LEDs are off. Turn it back on, and we get all the LEDs on again. We'll do some switching commands. Output 1, we will have it select input 1, 3, 2, 1, test. I can do more than that even. Output 1, select input 8. Okay. And we see the face of the unit just shows us some, it has an LED for each input there and allows you to choose, or shows you rather, what is the currently selected source for that output. And so we're able to test the commands there and confirm that this is the one we want. This is the device we need to work with, or in some cases, you might not find the code set that you need to work with. And so in those cases, we allow you to create your own RS232 codes. And in order to do that, you're probably going to need to refer to the product RS232 protocol document. So the MXA has something on the owner's manual, which we'll jump into in a moment. There's going to be some important information in there as far as the protocol of the device, how it communicates. Baud rate is the speed of the communication, or how many bits per second, for example. The pinout is also very important, letting you know which pins the RS232 commands are received, or the response is transmitted on the device we're controlling. Right? So typically 2, 3, and 5, just 3 pins are really used. And then, of course, the command data. What do the commands look like? And so as I scroll down in the owner's manual here, we see our commands for audio volume, SPO, which stands for, SP stands for signal processing, output XX, so your output number 01 through 08, output 1 through 8, audio volume, YY. YY is 00 through 99, so it's like a 100-point scale of your potential volume level for output XX. We have a mute, SPO XX, so output XX, audio video mute, enable, disable, toggle. So the AVM mute is PCM plus the analog audio, all 3 connections muted. And switching, to switch the digital and analog audio together, SPO, your output XX, select or switch to source YY, your input 1 through 8. Right? So let's go ahead and build this now. How do you build commands for a new device? File, new, the big blue plus. And you want to save it somewhere that is safe and away from our default directory. Why? Because when we go ahead and update to the new Compass software version, you might lose your work if you save it in that default directory. Occasionally we will wipe that library clean so that we could add our new code sets to it. I'm going to give it a name like Custom Key Digital Library. We tell it the brand that we're working with, the device type. This, of course, is an audio switcher, and the model number. Now we have that. Library name, the brand, the product category, and the device. And now we see we have no tabs here. We'll have only the one, common all. But this is an 8x8 matrix. It helps us to keep the library nice and tidy, and also helps us to understand things about the commands and the device rather, and attach the correct commands in places in our modular programming to provide the correct classification to units. If it's not anything like a matrix, you just probably, like if it's a monitor or something, there's going to be no outputs. Leave it as 0. The speed of communication, as we mentioned, is 57,600. But these are the device properties. So you might have devices as low as 1,200 bits per second, all the way up to 115,200. That's the range we support there. Additional protocol information, typically you got 8, none, and 1. Typically you don't have to mess around with that. Handshaking, what does handshaking mean? Well, some devices you can't just send it a command, can you? You have to ask it, are you ready to receive this command? And then it responds saying, yep, you're clear to send it. Some devices require that. Some devices require a carriage return, which is almost like a end of line. Some devices require a line feed at the end of each command. So because RS232 actually comes from the days of form feed printers when you had to say, this is the end of the line and begin a new line. And sometimes you need both of those things together, and one first or the other first. And in other cases, devices that are hex controlled, of course, we support, as we see here, ASCII, hex, and decimal formats. Some devices need checksums, which means they're different hex bytes, and you have to add and come up with a total as one of the bytes. So we support that, and we could automatically add that in for you, whether it be 8-bit or 16-bit, and all sorts of other terminators and automatic inserts that we support for your various devices. That over the years, of course, this has grown, and I'm sure something will come up in the future that requires a little bit more here as well that we could add in for you. Key digital devices actually do require a carriage return. They're ASCII format. We're going to enter the MC1000 here that we'd like to, when we actually get around to testing this, what port number and what IP address. And we can go ahead and add some functions here. Now, common all refers to the commands that apply to the whole device, right? So let's just do the basic power on, power off of the matrix, right? Action ID, I double click in here and I choose, this is a defined list of commands that are common. And this, you always want to choose an action ID. It allows Compass Control to know what is the command because you're speaking the software's language. And it allows Compass Control to very easily transfer one device to another. For example, if I had power on, power off, I have in my GUI, I have a power on button. I could make it one device, transfer it to a new device. So the old Blu-ray player, the new Blu-ray player, for example. And because there's an action ID there, we know power on is power on. Now the function name is whatever I'd like to name it. PWRON if I'd like, or let's be proper for the training. And now function data, that is what the command looks like. And power on and power off, if I take a look at this product, I could scroll on down to the operation manual where these commands are located. And we could take a look at the RS232 section. Let's see, here we are, power on and power off, PN, PF. Those are very simple commands, aren't they? Function data, power on, PN, power off, PF. So now I can actually go ahead and test that command. And it looks to have worked. Power off, the face of the unit, all the LEDs are gone, and now power on, command is back up. And I actually see a little bit of information here, but it's very, very brief. And the reason why is if I'm testing a function, this delay here, this is how long we keep that communication window open to receive the feedback. So let's go ahead and adjust that and now test our power off again. There we are. Now we have a more verbose feedback, don't we? So when we test commands here in the command table, it corresponds to this delay here because we don't keep that IP communication constantly open with the MC when we're in command mode. However, in test and terminal mode, I can actually connect and now see now keep the communication open with my master controller to see that feedback. So let me now test power off. Test again. There we are. And how about a very lengthy command? Help. The letter H. This responds with every single possible RS232 command we have. Let's go ahead and make this 3 seconds long and send the command. Send the help command and look, there we are. Much, much lengthier now, isn't it? So let's drag this up so I could see all these commands. Here's that switching command we saw earlier, output XX to audio input YY, for example. So help is actually a very valuable command, and we always put that in the Key Digital Matrix products and RS232 controllable products. Shows you all the commands you could send. So let us now move on to commands that aren't really to the whole unit, instead to one of the outputs. So for example, this is an 8x8 matrix. So let's go ahead and add 8 input commands. And I'll try to do this as fast as possible. So we'll do 8 input commands, but we'll also do a mute toggle command, a volume up command, a volume down command, because we have the incremental controls, of course, and then even the command that's for that's 00 through 99, right? So here's we'll do a mute toggle, like I mentioned. We'll do a volume plus, a volume minus. And you see it's organizing these by the action ID, the lower number at the top, because I have it filtered that way. And we'll also do a volume with a parameter, which means it could be any value, 00 through 99, or any value beyond that, actually. I'll teach you all about that. So starting with the input commands, input 1, let me just quickly name that. And what does the command look like? What does the command? It was, as we saw here, SPO XXSYY. So output XX, that's going to be 0, 1, and select input YY. So we have SPO 0, 1 for output 1, select input YY. So YY in this case is input 1, isn't it? Copy that with Control C and Control V. I'm able to do that, or any of the Windows shortcut commands or keystrokes. Okay, and output 8. Okay, now these are the commands, and I could actually go ahead and test these commands as well. So let me clear that window out and say output 1, select source 1, go ahead and send it. Let me exit my terminal mode here, and now test the function. There we are. Output 1, select source 1, back to source 8. There we are. And everything's working on the face of my my MXA 8x8 Pro. I see the lights moving for me as they should. So how does the volume up look? Well, let me give it my own name for volume up and volume down. We'll do the mute toggle. Let's give it a short name. I'm fine with that. And a volume. This is going to be a variable level command. So what do these commands look like? Without spending a lot of time going into the document again, it's SPO XX, so output 1 in this case, audio volume YY for the level, or up for U for up, and SPO 0, 1. Audio volume down. How about our muting command? AVM, SPO XX AVM, as audio video mute, enable, disable, or toggle. So we want T for toggle. So I'll test the mute, and on the face, there we are, we get my confirmation, and on the face of my MXA, I get confirmation by seeing, so it does a nice thing. It tells you, or shows you 1, 2, 7, and 8 on the LEDs. So the outer bookends are illuminated, so you can look at the face of the matrix and actually see that the volume is muted in case you thought you had a problem. I toggle that state, and my LED lights return to normal, and it says done, confirming that. So that all makes sense, right? But how about this one that I've kind of been working my way up to? Volume. As we mentioned, volume can be 0 through 99. Does that mean I should make 100 different commands? No, in Compass Control you don't have to, because we support advanced logical elements like a volume slider. You take your finger, you drag your slider, it stops at 65. Of course, you don't want to, you don't have to set 65. Instead, you could tell, you could speak to the system you can enter a command that interfaces with the system, and it's going to reference things like the value of the slider. It means that there's a variable in the command, right? So as I've explained it to you, the command is SPO, of course, XX. That's your output number, right? Well, in this case, it's output 1. And then the audio volume, that's how the command looks. And then YY. What is YY? The YY is the volume level, 00 through 99, right? Now, we can't just enter YY. Instead, what we have to do, or what we do in this case, is we use a parameter. Now, for information on the parameter, I'm going to go to keydigital.com and show you exactly how these look. In the compass control section, I have tech guides and videos. And I have this here, library parameters document. It's an Excel sheet. And so what we actually have to do is a percentage. The percentage is going to let our software know that this is where the command is going in, because YY might be part of a command, right? Or a variable. So the YY might be part of the variable. So we use a percentage to let you know this is where the variable is inserted. And then we let the software know what is the format. %D is used for integer, whole numbers. See? Whole numbers. Any value from 0 to 65,536. So for you computer people out there, you know this means it's a 64-bit system. %S for string. Any ASCII characters, that's letters and numbers, even symbols, that kind of thing. F for floating, that's numbers with decimal places. How many decimal places? 2 to the 16th power. %B for Boolean, true or false, where 1 is true, 0 is false. X is hex, so if you have a hex product, like an audio device out there, a lot of those work with hex. And actually, if you took a slider and the device needed hex, the slider's not in hex. It's still 00 through 99, or maybe even -60 to +12. So Compass does a great thing. It automatically converts your your integer value to hex for you. All you got to do is use %X there. And then %C is where we could insert a checksum if you did have a hex device that required a checksum as part of the command. So %D is one thing. That's what we're going to use because it's 00 through 99. But in our system, or for this device, the MXA, it requires 00 through 99, right? I take a look here at this again, and it says audio volume 00 through 99, if you can see my mouse. It's always 2 characters long. It's not 0 through 99. We won't accept it. So for that, we call it a pad. How long is your pad? So %D we know about, but how many characters in that parameter, that variable, is the pad? And we get to specify it here. 01 means it's 1 integer in length, 0 through 9. 02D means 2 integers in length, 00 through 99. %03D would mean 3 integers in length, 000 through 999. And if you're always requiring 4 commands, 4 characters, it'd be %04D, 000 through 9,999. Or if it's not specific, and it can just be anything as long as it's whole numbers, then you just get to use that %D. But in our case, it's always 2 characters long, isn't it? So let's start it off. Percentage lets us know that the variable is going in there, the parameter as we call it. It's 2 characters long and it's whole numbers. And what if the percentage was part of the command? Well, that's why we have to tell it by double-clicking the N parameter cell that there's 1 parameter there. And then it's always a good idea to make yourself a note. So you look at this later and you say, oh, parameter 1 is the volume level. And the potential values are 00 through 99. We save this command. And so now if I test my commands again, we have that output 1, select source 1. Let's go ahead and do it. It works. But now what happens here with the volume variable level? I can enter. It says, hey, I can't test the command yet. You got to tell me what is going to fill in the blanks. And I'm going to say, let's set it to 50%. I do that, and I get my confirmation through the terminal window. Plus, on the face of the MXA, we have a really nice feedback where the LEDs go to about 50% of the way. So this is great, right? Instead of making 100 commands, I get to make 1 and just use a parameter. So now we go on to the other outputs. Now, you know, there's some nice tools in there, but still this is going to be a little bit laborious, isn't it? So we have a really great trick here. Output 2, all the commands are the same. I just want to clone output 1. And typically in the RS232 and TCP/IP world, I'm just going to go in and tweak one character or maybe one byte in the command. So SPO, that's your output number 2 now instead of output 1. And do this one by one. It's almost like filling out an Excel sheet now. It's very easy. So now we could go ahead and test these commands, and we'll make it so that output 2 selects source 1. Let's clear our window here. I'm going to disconnect that terminal mode. In fact, I should go ahead and go back to command mode now. So output 2 selects source 1. Test that command. I get my feedback here. Output 2 selects source 8. How about the volume level? Output 2, volume level. Let's make that 20% there. And I get the nice blue feedback, or the nice LED feedback on the face of the unit that jumps to 20% on the blue lights there. Perfect. I could continue that all the way through output 8, just changing one character at a time, right? So output 8 here now, and just filling in instead of 1, making those 8. And this would work. This would work. This is now, say I've got 10 or 11 or looks like even 12 commands here. Of course, still takes time, doesn't it? And what I've already showed you is the parameter. Now, of course, the parameter is like a variable. I explained to you XX and YY. XX is your output number, YY is your selected source number, right? Or in the case of our volume command, YY is the volume level, 00 through 99. So wouldn't it be nice to just be able to make, one command that has 2 variables in it, your output number and your input number, or your output number and your volume level? We can do that. And we do that here in the common all because it's not specific to output 1, 2, 3, etc. It's going to apply to everything. So I add a function here. I'm going to add 3 functions, in fact. One of them is my switching command. And in here in the action ID, we even have a nice parameter or a nice action ID for that. And what are we going to call that? Variable switching. What does that command look like? SPO, right? Signal processing, output, XX, select source, YY, right? Except for, as I told you, it's not XX and YY. We have to tell it a parameter is beginning, its whole number value, and it's 2 characters long. %02D is how we say that. And we say there are 2 parameters now. So now give myself a little note. Parameter 1 equals output 01 through 08. Parameter 2 equals input 01 through 08. Shall we test? Let's do it. Test the function. Hey, I can't test the command. I can't send the command. I need to know what is my value for these 2 variables. Let's say output 1, select source 8, press OK. I get the feedback here, and on the face of my matrix, it's confirmed as well. What if I say, well, this same command could be output 5, selecting source 1. Test. I get confirmation, and I see it on the face of my matrix. So one command to replace 64. How about the volume variable? That would be output P1, volume P2. We have volume P1. In fact, it looks like we don't have the action ID for output P1, volume P2. That's okay. We can leave that as custom if we'd like. So volume variable, that looks like SPO %02D, which is going to be my output number, AV for audio volume, and then the level 00 through 99, right? So %02D. Again, 2 parameters. Test that function. Let's say output 1, we want to go all the way up to, let's say, 90% test. And I see that on the face of my matrix and the confirmation here. Or that could maybe be output 8 at 10% of the way. And just as before, I get the nice blue light indicating the level. And finally, the mute. Mute. So here's a mute toggle. I have that, or let's see, do we have a parameter with mute? Doesn't look like it. So let's just choose the mute toggle. And we call it mute variable. How does that look? SPO, XX, or your output number, replaced with 02D because it's whole number and it's 2 characters long. AVM for audio video muting. Now this is not numbers, is it? Audio video muting is, if we take a look here at our protocol again, E, D, or T, letters, enable mute, disable mute, and toggle. So AVM, parameter begins. Do you remember what it was for numbers, or for letters, excuse me? String, %S, all ASCII characters, up to 1,000 characters long. So %S, 2 parameters, and I get to say P1 equals output, again, 01 through 08. P2 equals E for mute, enable mute, right? D for unmute, and T for toggle. Forgot to fill it in here. Just do yourself these little favors while you're doing these things. It's always very helpful. So this is, parameter 2 was the volume level, 00 through 99, wasn't it? And there we are. Save. Okay, so let's go ahead and test that mute out. Test the function. What's the output? Source 1. Let's start with the enable mute. Shouldn't matter if it's capital or not. There we are, AVME. I see it on the face of my matrix, the 2 LED lights. Let's now test the D out. Let's go ahead and test the lowercase. Yep, it worked. AVMD, lowercase, not case sensitive, doesn't matter. And it's disabled, or to toggle between the 2 states. There we are, 2 lights indicating it's muted. Press it again, now it's unmuted. So there we go. I taught you now how to create commands, how to create your code set per output, and then to do the clone 1, which enables you to just go in and tweak a character here and there to make it appropriate for the new output, or to take what is essentially, if you have a dozen commands per output, 12 times 8, 96, and convert it to 3 commands by using the parameters. And then you just need to watch the C3 videos, which will teach you how to call those commands with parameters and to how to fill the values. So you could drag your finger on a slider and see that it stops at 65. So we send the value 65 to fill the parameter there. So with that said, that concludes C2 Part 3. And I hope you take that information and apply it to your application, and you could just see the power of compass control coming to shape.